Hello everyone, today I will discuss different types of inverter using MOSFET, and the content of my today's lecture is: first one is resistive load NMOS inverter, second one is enhancement NMOS load NMOS inverter, third one is depletion NMOS load NMOS inverter, and the fourth one is the most important one, which is CMOS inverter. Now already in analog electronics you have designed inverter circuit using BJT and resistance. So in this circuit what we have done, we have basically replaced the BJT using one NMOS transistor, and at the load we have connected one resistance. So this circuit will also work as inverter, because when input is high the transistor will conduct and output will become 0, because output will be connected with the ground, and when input is 0 then NMOS transistor is off, so output will be connected with 5 volt or VDD. So in this way this circuit will work as an inverter circuit. But the main drawback of this circuit is high standby power. What does it mean? High standby power means at the output terminal, if voltage is slightly less than 5 volt, there will be a voltage difference between this 1K resistance, and a constant current will flow from the battery. So battery will discharge very soon. And second disadvantage is we cannot fabricate resistance on silicon substrate, because it will take more space than fabricating an MOSFET. And the third disadvantage is the output, which will be treated as high for this case, that is VDD, but output which will be treated as load, that will be more than 0, that will not be exact 0. And this resistive load inverter is not used in VLSI technology, because the main drawback is we have to fabricate resistance which will take more and more space. Next one is enhancement NMOS load NMOS inverter. Why NMOS inverter? Because the driver, that means where we are giving the input, that is one NMOS transistor, and load is enhancement NMOS load, where gate is connected with the source terminal. Gate is connected with the source terminal means that transistor is acting as load, but this is called active load. So for load or for designing load we are using one MOSFET. That means what? It will reduce the space for fabricating than resistive load NMOS inverter. And in this case also the VOL will be more than 0, that is only drawback of this circuit. Next one is depletion NMOS load NMOS inverter. Again here we are using one NMOS transistor for the driver, and as a load we are using one depletion type NMOS inverter. And the depletion type NMOS inverter, we are connecting the gate terminal with the output terminal. That means that transistor is conducting even for 0 voltage. So in that case also this circuit will work as inverter circuit, but this is better than the first one, because again we are replacing that resistance using one active load. So this is the basic circuit of CMOS inverter. Now if we give one input and we change the input from 0 to 5 volt or from 0 to VDD, then for each and every voltage what will be the output? If we record that input voltage and corresponding output voltage, and if we plot that curve, we will get the voltage transfer characteristics of CMOS, which is very important, because where the transition is occurring, that is actually the threshold voltage of the CMOS inverter. That means if input voltage is less than the threshold voltage, that will be treated as 0, and if the input voltage is more than the threshold voltage, that will be treated as high. Now how we are getting these voltage transfer characteristics? basically we are getting the voltage transfer characteristics for different input voltages. Suppose we are giving at first 0 input voltage. So 0 means the lower transistor will not conduct, upper transistor will conduct. So we will get a load curve, and that will actually cut the x-axis in a point, and that will be my first Q point. Now if we increase that voltage, input voltage, suppose 1 volt, then again PMOS transistor will conduct and NMOS transistor will conduct lessly. So again from this driver characteristics and load characteristics we will get another Q point. Now in this way, if we vary the input voltages, so for different input voltages we will get a number of Q points. Now for all the Q points, if we plot input voltages and output voltages, we will get the voltage transfer characteristics of CMOS inverter. Now in previous slides I have shown the voltage transfer characteristics of an CMOS inverter, and that threshold voltage can change, it can decrease or it can increase. That will basically depend on these voltage transfer characteristics. Where it will fall, that will basically depend on the W/L ratio of PMOS and NMOS transistors. So if we can manipulate or if we can change or set the voltage W/L ratio of PMOS and NMOS transistor, we can shift the transition from left to right, or we can keep at the middle if we keep the W/L ratio of the two transistors equal. So in my next class I will discuss about different types of logical circuits which are designed using CMOS. Okay, thank you.